Welcome to Elite 10 Picks, where we bring you the best of the best. Get ready to dive into a world of unique and extraordinary discoveries. We're here to unveil the top 10 picks that will leave you amazed, inspired, and craving for more. Join us as we embark on a journey of exploration, where every episode brings you the finest selection of the most incredible things our world has to offer. It's time to elevate your knowledge and be a part of the Elite 10 Picks community. So today, I will tell you about top 10 failure of Ocean Gate. Number 1 is the Ocean Gate submersible. It was practically difficult for anyone with access to a smartphone, TV, or computer to avoid hearing about the Ocean Gate submersible. About 105 minutes after deployment, shortly after communications were lost, the craft vanished. To make matters worse, the controller featured in the Ocean Gate submersible was wireless over Bluetooth. Any engineer who has dealt with Bluetooth will know how unreliable Bluetooth can be. It would not take much interference for commands from the controller to be misinterpreted, or worse, a forced reconnect that could prevent control at a vital moment. Number 2 is the engineering behind Ocean Gate. However, the TITanic mission's failure highlights the significance of strict safety requirements and the requirement for knowledgeable supervision in such high-risk ventures. When it comes to the depths of the ocean, the unbelievable pressures experienced are so great that defects in a structure containing a low-pressure environment, such as air at 1 atmosphere of pressure, can quickly collapse, crushing anything inside. For example, at pressures of 300 atmospheres, a 1 cubic meter of gas at 1 atmosphere would be crushed to a volume 1/300 smaller. Number 3 is the carbon fiber hull, a dangerous choice. Steel and other solid materials are very universally used in submersibles because they are homogeneous or have the same material qualities in all directions. Since the behavior of the material is consistent from all sides, it is very simple to describe the forces experienced by a solid structure at any pressure. The Ocean Gate submersible, however, used a carbon fiber cylinder, which was not just a bad shape choice since carbon fiber, unlike steel, is not homogeneous. The strength of carbon fiber varies as a result of the fibers used. Thus, while it is strong in some directions, it is weaker in others. The properties of carbon fiber that make it unsuitable for submersible hulls include anisotropic strength. Carbon fiber has significant anisotropic strength in the direction of the fiber, but is less strong in other directions. Non-uniform properties. The strength of carbon fiber can vary depending on the direction of the applied force. Aging effects. Over time, carbon fiber can lose its strength and durability, especially if it is past its shelf life. Number 5 is the viewport, short-sighted choices. A small viewport for the crew to see the surrounding ocean was located at the front of the Ocean Gate submersible. Although many submersibles feature these viewports, the Ocean Gate subs apparently wasn't designed to operate below 1,300 meters. New York Times. 3. The viewport offers a possible weak spot given that the Titanic sits at a depth of 4,000 meters. Number 6 is the access port, trapped from within. Titanium was utilized to construct the dome that held the front viewport, which was probably appropriate for the depths involved. However, the design of the front dome, the only entrance and exit from the submersible, has led to concerns about emergency departure plans because it is bolted shut from the outside. This implies that there would be no escape route in case of emergency, necessitating the removal of the dome's bolts by engineers outside. Number 7 is the controller, a child's game. The use of a Logitech's F710 gaming controller as the only form of control was regularly cited as one of the design decisions that the media questioned. Even though it has been noted that numerous applications, including the military, employ game controllers, the truth is that even in these cases, the controllers are made to a much higher quality. In addition, there are auxiliary controls that are far more reliable when a game controller is utilized. Number 8 is off-the-shelf components, a cheap hack. Several electronic gadgets, including screens and lights, were contained inside the submersible. The CEO of OceanGate revealed in interviews that many of these parts, especially the lights, were purchased from nearby camping supply stores. Although the internal environment would allow for such technology, the safety issues raised by these parts imply they may not have been the best option. Number 9 is young engineers over experience, history doomed to repeat itself. There is nothing wrong with having young engineers. Everyone has to start somewhere, but in safety-critical applications, it is always essential to have at least 1 or 2 senior engineers with decades of experience. Younger engineers can present new ideas and methods that older engineers may not have thought of, but the experience of older engineers will ensure a level of safety and consideration that younger engineers simply don't have. Number 10 is the U.S. Coast Guard's investigation. The U.S. Coast Guard's investigation was established to examine into the tragic incident's loss of the Titan submarine and its crew. About 500 meters off the Titanic's bow, on the ocean floor, were the remains of the submersible Titan. Thank you for joining us on this incredible journey through the Elite 10 picks. Don't forget to hit that subscribe button and turn on notifications so you never miss an episode. If you enjoyed our content, give us a thumbs up and share it with your friends. Remember, the quest for the extraordinary never ends. Until next time, stay curious, stay elite. Goodbye.